Oh, hello, my name is Greg and welcome to the second chapter of my 1949 P3 Rover restoration story. In this chapter I just plan to cover the work that I've done on the generator on my P3 Rover. I did quite a bit of work in overhauling it, so I'll just go through that general process. Hope you find the chapter interesting. Now, just to start off the show, we'll start with, here we are with the car. I'll just move over the engine with a fair bit of work done on it now. And I'll just zoom in on the generator. There it is, whoop, down there. So there it is, that's the generator there. Looking quite a lot prettier than it once was. It was in fairly bad shape when I started. There was quite a lot of rust on it. It looked like there'd probably been a leak from this coolant pipe that had perhaps been leaking water on top of the radiator for quite some considerable time. Well, here's the generator in situ, just as I was beginning to remove it from the engine bay. A bit of a sad looking shot, I think, with the rust stains. Looked like there'd been a water leak from the thermostat housing and the water pump at the front of the engine. Initially I kind of had second thoughts about taking on the job of overhauling the generator, because I didn't really know much about generators apart from the fact that they made electricity. Well, here's the generator removed from the car, and what a pretty picture it is not. Lots of rust to repair there. Now, as I explained in the intro, there'd been a leak in a coolant pipe above the generator, although in the intro I think I mistakenly referred to the generator as a radiator. But anyway, there'd been a leak there obviously for many years. And I don't think there was any corrosion inhibitor in the coolant, so in the end you got a pretty predictable result. Just a closer shot of the generator casing here, showing the job ahead of me. You can also see the identification plaque on there, which shows that this is a Lucas generator from the Lucas's a special equipment range, which was just a higher specification range than their standard generators. As I understand it, it was a range that was typically used on sort of high performance cars, such as Jaguar during this period, but also obviously used by Rover. I began dismantling the generator, and I had a bit of trouble getting the nut off that held the front pulley on. So I made this tool just to help me, which is just simply a piece of plate welded to a piece of bar with a large hole drilled through the plate to allow me to put a socket on the nut that held the pulley on. Worked pretty well, managed to get the pulley off pretty quickly. This shot shows the inside of the generator with the two fuel coils there. I was sort of learning about generators as I went along, and it was an interesting learning process. I wanted to remove the two fuel coils because I had a lot of repair work to do on the casing, which involved doing quite a lot of welding on the casing. So I didn't want the fuel coils there. I didn't want to cook them. This shot shows the rear end plate of the generator as I was removing the ball bearings. It looked like it still had either its original ball bearings or at least the original style of ball bearing. In the end I opted to replace both front and rear bearings with modern seal bearings. The front bearing in particular was shot really. This is a front end plate with the bearing removed, showing all the surface rust, which actually cleaned up pretty easily in the end. To remove the fuel coils, I had to drill a rivet out that held this post in place. Took quite a lot of little photos really just to help me with the reassembly later on. In this shot I'm just beginning to remove the fuel coil wrapping. The fuel coils were wrapped in a sort of cotton tape, which was then painted with shellac to provide insulation. They were in okay shape, but not great, so I just wanted to remove the old insulation and see if I could improve on it. I took this shot just to help me with reassembly later on. Now, as shown in some previous slides, I had a lot of rust repair to do on the casing of the generator. So what I did is I chipped the rust out and then ground the rust out until I got to a clean, shiny metal, which then, of course, created quite a depression in the casing, which I then built up with weld, lots of weld. And then the next job was to turn the casing back down so that it was nice and smooth and round again. To help me with that, I made this tool, which I'll explain as I go through the slides. Now, I designed this tool to hold the casing so that I could turn the whole length of the casing in one setting on the lathe, but I'll do a short video later on just to show how that process worked. Well, hi, with this video I'm going to try and give a briefish description of the fixture that I made for my generator. I had to make a fixture to turn down the outside diameter of the generator after I'd done some repairs on the casing by welding it up. So I made I guess it's a fairly simple fixture. It has an end plate that end and an end plate that end. I simply used a piece of solid steel bar like so, which I cut 2 pieces, welded them together, and then I turned a step in it. So this diameter that I'm running my finger across here corresponds with the inside diameter on the generator casing, and the same on the other end. This end, you probably can't see it, but this plate is welded to this shaft. This shaft is just made out of bright mild steel, and then on this end, as I said, they're very similar end plate, but the difference is I have a screwed end here, so I can put a nut on here and then effectively tighten this plate against the generator casing and thereby clamp it. When I actually did the job, I didn't use the 3-jaw chuck that you see here. I used what's known as a 4-jaw chuck. The 4-jaw chuck allows a greater degree of accuracy, so effectively you can adjust the workpiece in any direction, and then using a device like this one here. This is called a dial indicator. Dial indicator has a plunger, and as you push that plunger in, the needle moves around. It's a very accurate measuring instrument, really. Each division on this face represents just 1/100th of a millimeter. So if you push this in, you can measure exactly how much it's been pushed in. That allows you to do a lot of setup jobs. So if I want to get this shaft running perfectly truly, I can use it for that. I can also use it for the second part of the setup, which I'll try and explain. So here we have the tailstock. In the tailstock I mounted what's known as a live center. It's called a live center because this part rotates. And then just to explain how that was set up, I used what's known as a center drill that I have here to drill a hole in the end of the shaft. That gives me a nice 45-degree taper, which matches the 45-degree taper on this center, so that as you push that in, it locates very accurately in the middle of the shaft. You then lock up your tailstock like so, and then you can, using this hand wheel, tighten it up so that this still rotates freely, but effectively this center both supports this end of the shaft and locates it very accurately. The reason I wanted to use this was it's a fairly long workpiece, so it needed to be supported in order to minimize the amount of vibration. The other advantage with the tailstock is too, you have an adjustment screw here and on the other side where you can adjust the offset of this centre. And again, using the dial indicator, I could run the dial indicator along the entire length of the workpiece and determine, okay, it's cutting a bit of a taper here, running at a bit of a taper. So then I could adjust this tailstock so that it's running perfectly parallel. In the end, what I wanted to achieve was to clean up the excess weld build-up on the casing, but not to take any more material off the casing than absolutely necessary. I didn't want to actually reduce the diameter of it. I hope that kind of explains what I did.
This shot shows my turning fixture in action. By the time I'd taken this shot, I'd already machined off most of the excess weld. So at this point, we're getting pretty close to the finished job. This shot just gives another angle on the job, so to speak. But you can clearly see the live centre supporting the end of the workpiece. And as I mentioned earlier, that's important because on such a long job as this, if you didn't have that support, you would get a lot of vibration as you're machining it, and that would give you a very poor surface finish, which is not what I wanted. In addition to repairing the rust on the casing, there was also this steel strap that was wrapped around one end of the generator, and this covered where the generator brushes were. It was also very rusty, but just sort of rusty in the middle section. I wanted to retain either end of the strap because that had a fitting in it where a bolt went through. So that's what I did. I just cut out the rusty section, and then I cut a new piece of steel to fit in, welded that in, and then ground the weld flat, and then painted it up. And yeah, it worked out alright. You did not know that it was repaired in the end. Just starting to put everything back together again now. You can see the repaired casing there, all painted up, and also in the foreground that strap that I mentioned in the previous shot, all repaired and painted up as well. Starting to rewrap the field coils now, which was an exercise in bandaging really. For rewrapping the field coils, I just used this Scotch 27 glass cloth electrical tape, which just comes in a roll like so. It has an adhesive backing on it, quite easy to use, and yeah, a lot less trouble than sort of going to replicating the original field coil wrapping. When I initially removed the field coils, I had to drill through this little assembly that you see in the middle of the shot here, which consists of an electrical insulator and a sort of brass spacer, and also a sort of rivet through the centre of it. So I remade all these bits myself and then reassembled. And this is a shot of the assembly, almost ready to go back in, where I've made that little white sort of insulating piece out of engineering grade plastic, and also the brass fitting that fits alongside it. This is perhaps a better shot of that whole little assembly ready to go back into the generator. Just fitting some new generator brushes now. I managed to find some new brushes from a supplier on eBay. Here's the generator pretty much in its final assembled form, and I have to say I'm pretty proud of the end result. You have to say it looks a whole lot better than what I started off with. Now in the end I did have a lot of fun and games actually getting the generator to work. I put it in the car, tried it out. It sounded okay, didn't make any squealy noises because I put new bearings in it, but it didn't seem to generate any electricity either. So I took it out again, couldn't really figure out what was wrong. In the end I did a bit of searching around, and I found an auto electrician that still works on these old generators. He had a look at it and complimented me on my work, which was nice, but he did find one small problem. There was where the two field coils joined together at a solder joint, and I hadn't done a very good job on the solder joint, but he fixed that up for me, and then tested it out, and it worked very well, much to my relief. Well, here's a generator back in the car, looking a lot prettier than it once was. Also done a lot of other work here at the front of the car. There's a supporting cross member there that supports the radiator. I had that out, had it sandblasted, did some welding repairs on it and repainted it. Also the supporting structure under that I've done some repairs on and repainted. The harmonic balancer at the front of the engine I've had off, cleaned up, repainted, and also the fan. Just included this shot as a before and after shot compared to the previous shot. So yeah, just gives a bit of an idea of the progress made. This will be the final shot. Now, as I mentioned, I think earlier in the slideshow, I was a bit reluctant to take on this task of overhauling the generator at first, mainly because I wasn't at all familiar with working on generators. But in the end, I'm glad I did take it on. I've actually enjoyed the process. I also did a bit of research before taking the job on. I looked on eBay and I was able to find one or two examples of reconditioned generators of a suitable model and vintage. But for one in good condition, you're looking at about $1,000. I figured it was worth investing a bit of time and energy into the job myself. Anyway, that's all for now, and I hope you enjoyed this show, and stay tuned for the next episode.